Places, everyone. I'm gonna shut this window too, because we got the weirdos outside.
That's kids if you guys are new to this.
I'm in a neighborhood with very strange children.
That's the one school lets out. Some weirdos are about.
So occasionally, apps deal with money. And I know that can be shocking. They are pretty rare. This seems straightforward enough, given basically every app deals with money in some way or another. But there's actually a lot of complexity involved when dealing with money, especially when you've got to do math with it. It's really important that you handle the data driving that currency properly. And a lot of founders and non-technical people don't even know that currency math is a thing. I mean, hell, even junior developers don't typically know that currency math is a thing. They just take a straightforward approach and think that's good enough.
Currency math refers to calculations involving monetary values, such as adding and subtracting amounts of money, calculating taxes, and calculating exchange rates. When you're performing these calculations in programming, it's important to be aware of the potential rounding errors, which can occur just due to the way computers store and manipulate numbers.
Yeah.
Like rounding errors can occur when a number is being rounded up or down to a specific number of decimal places and then used in further calculations. Like, for example, if you round 1.005 to 1.01,
you've just lost 0.005.
Yeah. And if that value is then added to another value that's already been rounded, this will result in slightly different values from the original unrounded amounts.
Yeah, that makes sense. And I mean, this isn't even limited specifically to programming. There are a lot of fields that deal with this, and it's called significant digits. And even, and like least and most significant numbers. In a previous life, I was doing a lot of chemistry work. That's what I was pursuing a bachelor's degree in. And even there, it was measuring molecular weight, all that stuff. You got really, really small numbers. And if you rounded too early, rounded the wrong way, then lots of problems could occur. And someone may or may not have been blown up. I don't accept any responsibility for what happened in that lab. But anyways, it happens everywhere.
Dark.
Well, we can't all be Adonis, Jacob. But anyways, it's a really important thing. And it's, currency is not special in that regard, but it is important to keep an eye on that and watch out for those kinds of things. And this may sound pretty hypothetical, but it's actually been exploited a lot. Sometimes on purpose, most of the time on accident. Like in the 1980s, I think it was the Vancouver Stock Exchange. They used the wrong function to round with. They used .floor instead of .round. And what that does, for the people who don't know, is .floor takes whatever number you've got. So if you've got like 1.05, it'll cut off everything after the 1. So everything under the decimal point, it'll just take it off. So 1.05 round or .floor is 1.
Mm-hmm.
.round will round it to whatever it's supposed to be. And so if you got like 1.5 or 1.6, it'll round up to 2. If you got 1.4, it'll go down to 1. Floor just takes that completely away. Anyways, the stock exchange over the course of like 23 months, so roughly 2 years, lost about 50% of its value because the logic that was going on the code side of things was using .floor instead of .round.
And that's not even like fractions.
No.
That's a big difference.
It was a major problem. And that is a thing that actually happened. So it's not just hypothetical.
Yeah. And just being involved in the programming world and classes, and as you start researching currency math and issues involved with that, and you and I got pretty involved with that when we were doing some crypto wallets and things,
Mm-hmm.
and that kind of like made us dive in head first, and we understood the concept. But you always hear these stories about, the bank that got swindled by a programmer.
I dare say bamboozled.
By a programmer that used bad rounding on purpose, right? So he was skimming fractions of a cent off transactions, and he didn't get caught for like many years until it was in the millions of dollars that he was stealing. So decades even, probably.
Yeah, probably.
And the thing is, though, like, this is a realistic situation, and like people are aware of it now.
Yeah.
But like, it's like where all these shows came from, right? Like Office Space.
Yeah.
They just messed up and it did it all overnight instead of the played out fraction of a penny.
Mm-hmm. And then this was literally the plot of Superman 3, and Hackers was another one that used this story as a basis for it. Like this almost has urban legend status. Mm-hmm. Because there aren't a lot of details on who done it, when it happened, how much it was. But that also makes sense, because if I were a bank and I had gotten screwed out of millions of dollars,
you're not going to talk about it?
I'm not going to publicize that info. But this is also like, the term for that is technically salami slicing. And it's a real thing. It's a way that people steal money all the time in various ways. But that's the term for it, because, you're just taking thin slices off the end over and over and over again.
And it's a hard accounting mistake to catch.
Mm-hmm. Especially when you're dealing with, it wasn't even like he was stealing a full cent or anything here and there.
Right.
It was some transaction came out, like stock purchases. You're dealing with, I'm buying 400 shares of this stock at 12.001 cents per share. He was essentially just taking that 0.001 and slicing it off the end. Mm-hmm. So when you're accounting things, unless you're carefully looking for it, you don't notice it. And it wasn't even like, here's 400 shares, it was 1 or 2. Mm-hmm. So basically invisible, super hard to catch. And this is something that's also pretty common in the crypto space. Like when we were working for that one client building a wallet, that's when, at least for me, it kind of hit home, and I started realizing how in-depth and how heavy all of this was. Because I was seeing the currency math going on that these engineers who had built this blockchain were using. And I was like, this is dumb. And then after we used it for a little while, it was like, oh, this is not dumb. I'm dumb.
Yep. Yeah, you realize how little you know until you start to learn it.
Yep.
And yeah, so to avoid rounding errors in currency math, it's important to use appropriate data types and rounding methods in your programming language. So to keep some tips in mind, you want to use like the decimal data type.
Yeah, and this is more of a database thing, right?
Yeah.
Like database side.
Yeah, which is also known as fixed point or arbitrary precision data types. They're designed to handle numbers with fixed numbers of decimal places. And like other people will be more used to like floating type integers, mm-hmm. or floating type numbers, I should say, because that's usually what we use for decimal numbers.
Well, yeah, when you see like 12.05, you immediately think like a float or a double.
Yeah, and a float is... I'm not actually really sure how the rounding works, but I know it's not.
It's complicated, but it has to do with the amount of memory that's available at that time, okay, and how accurate the computer can get it. But it's also well documented that basically every language, you have to be aware that if you've got a float, after so many decimal places, it's not going to be
accurate,
exact.
Right.
And that's where like decimal comes in, because Postgres has the decimal type, Swift has the decimal type. I'm not currently aware of any languages that natively support it, but I'm sure there are. But they built those types specifically for things like money or, heavy duty chemistry equations and that kind of stuff, where the number of significant digits and even out to like hundreds and hundreds of thousands of places, like beyond the decimal point.
Wherever precision is required, right?
That's where I was going with this.
Yeah.
But wherever precision is required, that's where the decimal type comes in. And even in like Swift's documentation, it says don't use this unless you have to, because it's not very efficient. And outside of that, like, most people think float, and it's not as reliable as you think it is. Another thing to look out for is to make sure that you're using rounding methods carefully. Like, you want to be aware of what you need to do and make sure that you're using the right one for the task at hand. For example, if you're calculating sales tax, you want to make sure that you're covering any discrepancies, so you'll typically round up. Like, if the sales tax calculation comes out to, 10.3 cents, you're going to want to do 11 cents to make sure that it's covered. Whereas if you're looking at like a total balance, you may just want to round to the nearest cent depending on the situation. So you want to make sure that you understand the requirements of whatever you're working on. And this is important for really anything, but it's especially important with currency math because nobody likes losing large amounts of money very quickly. I mean, it's going back to something I talked about in the past. There was that other developer that I know who made the mistake of scheduling that homeowners association withdrawal every 5 minutes while he was testing and never changed it back to once a month. And like overnight, people's accounts were getting drained.
We will forever call this situation the office space.
Yes. And it may sound like office space, but this really happened. But anyways, that kind of thing can get you in trouble really quick. And it's the same with rounding methods, with really any currency math. If it can be exploited, like if somebody's coming for you and they want to exploit a problem, they're probably going to do it as fast as they can and take off with as much of your money as possible.
Yeah.
So rounding methods are another way that people can exploit that, or where problems can come up. And you want to be really sure that you're using the right ones.
Yeah, and avoid intermediate rounding. If possible, you want to avoid rounding until you have your final result.
Yeah.
So you want to keep everything as precise as possible until you have to make it in, like, obviously money only has 2 decimals.
Yeah.
But you don't want to round that until you're...
Yeah, and for the people who are less technical that are listening, what is intermediate rounding?
Intermediate rounding would be taking, 2 values, you're either adding them or doing some sort of multiplication or math process to them, and you're rounding them individually, then combining them and rounding them again.
Yeah, so it's like that example you were sharing earlier of if you've got, what was it? 1.005 and you round that up to 1.01. You don't want to do any rounding until you're at the very end of the process.
Right, because let's say you're just adding that 1.005, but you already rounded it to 1.01, and then you add it to like the same value. What, you have 2.02 now instead of 2.01.
Yep. And that's a small number.
That's a small number, but the 100th place adds up quick. That's a penny.
Yep.
So that's already a penny off just with rounding those numbers early.
Yeah. And again, like with crypto, when you're dealing with things like gas fees, transfer fees, whatever they're called in the blockchain that you're using them, it's typically not, okay, well, I want to make a transfer, so it's going to cost me 1 Ethereum or 1 Ether.
Right.
It's going to cost me like, well, I don't know about Ether, but just as an example, it could be, it's going to cost you 0.000000001 Ether.
Right.
And so when you're getting to those really small values and you've got a whole bunch of transactions going on all at once, it can make a huge difference. So avoid intermediate rounding. And when you're dealing with the math for currency, if you don't have a decimal type available, like we were talking about earlier, typically you'll want to use something involving integers. Like typically what I'll use if I'm not using a third-party library that I've already verified, which we'll talk about in a second, is I'll have the integer as a whole number, and then I'll also pair that in an object with an exponent, like a power, how it's significant digits, whatever you want to call it. And for example, if I've got, $10 and I want to represent that, then I can represent it as, 1 with 3 zeros, so as 1,000, and then have a power of 2. And that power variable just tells me how many times, like how far over I'm moving the decimal point. And that can be really helpful with things like, okay, we just made a transfer with 0.0001 cents. I can put 1 and then put however many as a negative and say, okay, I got to move this over. And then you end up with that end result, but you can still do all of the math with integers and not rely on any floating point decimals where anything could go wrong.
Right. Then you're always handling the integer, and you really just spit out either a string version of the decimal, or you can convert it to a float or double just for readability.
Yeah, and you can use functions that exist, like every language has them, but you can use formatting functions to round things, cut it off at a certain precision, all that stuff.
Exactly.
And display it however you want to. Like my account balance could be $10 and 0.0001 cents, but I can just display it as $10.
Right, exactly. At the end of the day, there are just certain things that you just don't want to reinvent the wheel with, and one of them is security, and the other one is currency math, in my opinion.
That's one of the reasons I use things like Stripe when I'm implementing payments and that kind of stuff, is because, like, I don't have a team of lawyers at the ready and security professionals who are making sure every transaction is just fine and all that crap. So, with security, you don't want to mess around with it and end up with a lawsuit.
Exactly. But like, even like as you're calculating what you're passing into Stripe, just using a well-tested library that's, proven and abused and been tested, and people have run it through the ringer way more than you have.
Yeah.
But you usually want to do that.
Yeah. My personal favorites are the libraries written by dudes out of like Albania with 1 star attached to it and no reviews. Like, that's what I typically rely on. That's
please use, trust me. Put your wallet private key here.
Why do all the account details go to a remote server? I don't understand.
So yeah, using just a trusted library for currency math is the easiest and safest way to not F it up.
Yeah, for sure. So I would recommend using a library whenever you can. But if you can't, for whatever reason, then just stick to like integer math, making things as clean as possible, and just be aware of these problems. Because if you're just displaying numbers, then fine, who cares? But if you're doing any kind of math with currency, it can get really tricky and you can cause a lot of problems really quick. So it's important to be mindful of things like rounding errors, that floating point precision, and all of that stuff in programming. And you want to make sure that you're always using the appropriate data types and rounding methods for whatever you're doing to avoid things like, the intermediate rounding, and using well-tested libraries, like we said, because that can help ensure the accuracy of everything that you've got going on, everything that you're doing, and it keeps you safe, your customers safe, everybody safe.
Yeah. Yep. You could even, if you really want to flex your skills, you could do binary math.
You could. I could also gouge my eyes out. Just kidding. Binary math isn't bad. But yeah, you just want to make sure that you're being safe, especially when it comes to money. Because like account details, oops, something went wrong, are bad, go back and fix your account or whatever. Money, people get real upset real fast.
Yeah. Oh, write tests. Anything with money, write tests.
Yeah, 100%.
I don't know if we've said that in the past, but
I think we did when we were talking about test-driven development, but
for sure.
Absolutely, this is why tests are important.
Yeah. Failing tests, passing tests, all the tests.